Right, I was wondering when I knew how to start and when. Hello. I guess we're starting. Yes, so I'm Trisha. Hello. I'm a developer advocate for JetBrains. I work mostly with IntelliJ IDEA and Upsource, our code review tool. And today I'd like to talk to you about refactoring to Java 8. In the past, some of the presentations I've done have been around how to use new Java 8 features, and a lot of the presentations you see on this topic are around sort of thinking in terms of Java 8 and how we apply them in a kind of greenfield type application. And what I really wanted to look at is something which is a bit more like how we as developers work in the everyday world, which is we have a code base, an existing code base. How do we perhaps migrate this to use Java 8 idioms, and should we do that as well? So I should warn you, I added approximately 45 slides to this presentation last night, and it already overran before I did that. So I'm going to talk very, very fast. Also, the initial content for this presentation has been given before at Devoxx UK, so I'm going to skim very lightly over it, and if you're interested in more details in the introductory stuff, then the video from Devoxx UK is available as well. So yes, let's get on. Firstly, let's talk about why Java 8 before we start talking about migrating to using Java 8. Let's just skim over this really quickly because this has been discussed a bunch of times. Firstly, it is faster. Generally speaking, when you use Java 8, it's faster. There's a lot of different reasons for this, but it's probably one of the most compelling reasons for the business and for your ops people. Moving to Java 8 generally gives you performance improvements. It is, of course, easy to parallelize, which is one of the main selling points, and the question is, should you, really? But we'll look at some of these examples a bit later on in the code as well. There's fewer lines of code. A lot of the new idioms, Lambda Expressions in particular, helps to reduce the boilerplate in your code. And that's kind of considered to be a good thing. As a long-term Java programmer, I really didn't care that much about this because my mind sort of ignores boilerplate. But hopefully, as you'll see throughout this presentation, it actually can make things much more readable to have fewer lines of code and less boilerplate. Lambda Expressions and some of the other features like optional and the Streams API can present you with new solutions to problems. So, for example, being able to pass around behavior instead of objects in terms of Lambda Expressions can help you design things in a slightly different way, which can help you solve things perhaps better or solve things you couldn't have solved before. And I think an area which is underemphasized for Java 8 is it does help you prevent, sort of minimize errors in your code. Optional is one of the areas that does this because we can reduce the number of null pointer exceptions. But also things like Lambda Expressions can help us reduce things like copying and pasting errors and stuff like that. And we'll see examples of this as well. Now, before we sort of dive in and start looking at this, oh, you know what? I was supposed to ask you guys something first. Who's using Java 6? Millions of you, you poor buggers. Who's using Java 7? Most of you. Who's using Java 8? More of you. Are we talking about multiple projects here where you use multiple versions? Because some of you are just putting your hand up because you need the exercise. Who's using a Java 8 compiler but really writing Java 6 or 7 code? Okay, a smattering of you. So this is kind of aimed at that. So how do we move our code forward as well as the compiler? Before we start talking about refactoring, though, I want to talk about our safety harness before we start rewriting code. Before we refactor anything, we really do need a good set of automated tests. We need good test coverage. We could have a very dedicated QA team, but I would hate to do that to them. So automated test coverage is a much better way of catching to make sure that we haven't unintentionally done something we didn't mean to. If performance matters to you, you should have performance tests and run them occasionally. And I'm not necessarily talking about nanosecond, low latency, high frequency trading. I'm talking about responsiveness to the user. So we could be talking about half a second response times. But if performance matters to you in any way, shape or form, which I would argue for a large chunk of you that's true, you need to have some performance tests to sanity check you haven't done something silly. If you're going to do refactoring, you do have to decide upfront, you as a team, have to decide upfront why you're doing the refactoring. Because there's a bunch of different reasons to do this. Now, I'm going to talk a lot about performance, but and that's quite a compelling reason for sort of management or operations. but there are a bunch of other reasons. For example, you might want to refactor an existing code base to Java 8 to safely learn about Java 8, understand some of the trade-offs, so that instead of having to learn a new project, a new domain, a new everything, and Java 8, you can be learning it in the safety of an existing well-known product. So there could be a bunch of different goals for why you'd want to do this refactoring, and they're all valid, but probably you don't want to adopt all of the goals at once. Like maybe one or two would be a good idea. And when you're doing individual bits of refactoring, definitely limit the scope. So maybe start at a sort of method level, maybe sort of class level. One of the refactorings I did, which I'm not going to talk about because I keep doing it wrong every single time, is trying to implement optional. And that, because it's an API level change, can impact your whole code base. So you sort of impact like 600 class files, and you've got this massive check-in, and no one can code review that, and you don't really know what you've broken. So try and limit the scope as much as possible when you're doing refactoring, certainly when you're starting off. Now, the code I'm going to look at is a project called Morphia. This is an object document mapper, which is basically Hibernate for MongoDB. There's a few reasons for this. One, it's open source, so you can look at the code base and have a look at the sort of before and after of these changes. Two, it's kind of small enough to get your head around, but big enough to have reasonably complicated bits of code like you find in a real code base. Three, it's a few years old, so you sort of start to see some of the archaeological history of different changes in styles of coding and some areas that are ripe for perhaps being marginally better than they are right now. So it's more like a real-life code base. It's a good way of demoing how to use some of these features. Let's go straight in. We've got 54 minutes for about 150 refactorings. Firstly, let's look at refactoring to using Lambda expressions. This is an area where you can use automatic refactoring quite easily. Some of the areas that refactor quite easily are changing anonymous inner types on predicates, comparators, runnables, etc. to use Lambda expressions. So let's get straight in. I put mirroring up. Why isn't it mirroring? I definitely tested this. I might need some tech support at some point. I do have mirroring set up, but apparently it's just ignoring me. I won't say anything about Windows at all. Display preferences. There we go. Duplicate these displays. Apply that. Keep changes. So now I've got only 103 changes to show you in the next 53 minutes. Okay. Let's get my script up. So what I've done is I'm using IntelliJ IDEA. Obviously, I mean, I work for JetBrains, but I would have used it anyway. I will be showcasing some of the features in IntelliJ IDEA, but it's not meant to be an IntelliJ IDEA talk because Eclipse and NetBeans do have some of these features in anyway. So it's more a case of if you know how to use your tools to locate things like make these refactorings, then these are the sorts of things you should be thinking about as you apply those changes. So I've run a bunch of inspections. There'll be a link at the end which shows how to run the inspections. That's really not the exciting part of this talk. And these inspections are flagging up places where we can use Java 8 features. For example, this says that this anonymous inner type for predicate, which is a guava predicate, can be changed to a lambda expression. So we will do that. And that's quite a straightforward change. If we look at the changes that have happened, then we basically get rid of all the boilerplate. We get rid of all the types and all the method names and all of everything, so we end up with just the sort of business logic from that method. And that's what we have inside our Lambda expression. So we don't need to worry too much about, well, we do need to test it. We don't need to worry too much about the impact of this change because it functionally does the same thing it did before. So let's skip straight on to some other examples. These are not the most exciting examples, getting the IDE to make these changes for us. Another place we can do it is we may have been creating runnables all over the place, so we just replace that with a Lambda expression. And again, not super exciting. We just keep the core functionality of the anonymous inner class. So we can kind of apply those across the board without worrying too much about it. We'll look at the performance of that in a minute. Another place is callable. Now, if I refactor this one, what we end up with is a multi-line lambda expression. Me personally, I like to refactor multi-line lambda expressions into a separate method. So I'm going to call this found 10 items. And there's a few different reasons for that. One, we have a much smaller amount of code, which is kind of nice. Two, it reads better. I can see I'm doing this until I found 10 items. I don't have to kind of parse this set of code to figure out what it's doing. And three, if there is an exception, the stack trace is a bit friendlier if the exception is thrown inside a method like this. So I tend to prefer to keep my lambda expressions very short or delegate down to a method. Now, so that's kind of fairly straightforward. Oh, good, well done. Now you can see all my notes where I say, don't talk about this, and ask them that. Oh, really? Safety, blah, 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 morphia, automatic refactoring. Right, so that's fine if you've got interfaces and you are implementing an interface like runnable, like callable, and you want to implement it as a lambda expression. Now, what you might find is, I bet you any money when I go out of this, it's not mirroring anymore. You might have abstract classes with a single abstract method. But unfortunately, if I show you an example of this, I've got one here. This is an abstract class, and I have a single abstract method. But if I look at an implementation of these, I can't turn this into a lambda expression because lambda expressions can only be applied to interfaces with a single abstract method. So what I'm going to do is I'm actually just going to get IntelliJ to turn this into an interface. I can then flag this as being a functional interface so that I can implement, so that implementations can be lambda expressions. So now when I go into my implementation, I can just replace that with a lambda expression. So it's just a small subtle point, but lambda expressions can only be used with interfaces. So you might want to do a search for abstract classes which you can convert to interfaces so that you can use lambda expressions. This is not the best way to view the slides. I have a backup plan. Oh, you know what? You can read that, can't you? No? Okay, fine. Huh? There should be a second button. Oh, I know, I clicked on the wrong one. But I'm just going to have to come out of that again in a minute anyway. Right, so let's look at the performance of lambda expressions because I've just said willy-nilly, you can just apply them across the board and not worry about it. So let's look at one of the examples here where I had an anonymous inner class and I converted it to use a lambda expression. So I've done a performance test using JMH, which is an amazing benchmarking tool, and it shows me that my lambda expression performs marginally better than my anonymous inner class. So that's good. So we can apply that and forget about it. Of course, Oracle did a bunch of work around performance testing lambda expressions when they were working on Java 8. So there's a much more fully featured document which kind of shows the trade-offs for different types of anonymous inner classes and different types of lambda expressions. So you can see that sometimes lambda expressions don't perform quite as fast as anonymous inner classes. But generally speaking, the performance is fairly equivalent, so you don't have to worry about it too much unless you really care about the sort of nanosecond latency type things. By the way, I always find performance charts kind of confusing because I'm not sure whether the bigger number is a better thing or not. So I put my smiley faces and sad faces so that you can figure out whether a big number is a good thing or not. So my performance analysis of lambda expressions is, I'm saying inconclusive to mean it's not really better or worse performance-wise in the examples I've looked at. So you can kind of make your own decision based on whether you think it looks better, whether you're going to refactor to using lambda expressions or not. Okay. But I've talked about doing just a straight replacement, but I want to talk a little bit more about that. How can we design using lambda expressions? I want to pass lambda expressions around where perhaps I wouldn't have done it before. So I've created a structural search to look for places where I'm logging something. this structural search says, okay, I found a log.debug. Now, when I do a log.debug, I'm going to create this string, and this variable here is actually a list. So when I call the debug method, it goes into the list, it builds up the string representation of that list, and we don't know how long that list is. And then if I'm not actually logging at debug level, I then just drop that string on the floor and don't do anything with it. So I've incurred a performance cost that I didn't necessarily need to take just by creating a string. And it's easily done. And so often, this is why you often see if log.isDebug enabled, and you should see log methods wrapped in something like that, because it stops you incurring this cost that you don't need to. Now, what I want to do instead is I want to create a new method on my logger, which takes a lambda expression instead. And this is a subtle change, because here now I'm providing the recipe for creating the string rather than actually building the string. So let's create this method, see what it looks like. It's going to take a supplier of type string. Let's call it string supplier. And so then this takes a lambda expression, a recipe of how to build this. Now, obviously, because this is on an interface, I'm supposed to implement that method on all of the loggers that I have defined. And I don't really want to go into all the different loggers and implement this method, especially when I have a default set of functionality for this method. Fortunately, Java 8 has default methods on interfaces. So I can create a default implementation for this. And I know what that looks like. I want to say if is debug enabled, then call debug with string supplier.get. And only at this point do I build up that string. Only at this point do I go into the object and try and find the values and smoosh together the string, only if I absolutely need to. And on top of that, I don't need to implement this method in all the different loggers. I've already got the default implementation right there. So that's good. That's good for performance because I'm wrapping it inside the if statement. The other thing it's good for is if I look at this class here, 357, when you're kind of reusing code in this way, copy-paste coding, it's quite easy to end up with an error like this. So I've got an info call inside is trace enabled. But if actually instead I'm calling the lambda method, which has the if statement inside it, I've basically removed that copy-paste error from everywhere. It's just contained within the one place. So here's a place where Lambda expressions can help reduce some of the errors by allowing us to kind of create the boilerplate in one place and inject the Lambda expression, which will be executed in the middle. Let's undo that so we still compile. Okay, so let's look at the performance of this sort of lazy evaluation. What I've got is I've got a bunch of different methods. The first two take, I don't have a mouse up there. The first two take a constant string which isn't changing, and the second two take a string which is more like the sort of strings we see when we're logging. It takes some value which is going to be appended, so I have to create that string. And we find that when you're passing in a constant string, obviously the performance is pretty good because it doesn't really have to incur any sort of cost. But when we have to build up a string but not do anything with the message, so this is if we're not actually logging the message, then that blue block on the right-hand side, that's where we're incurring the cost of building up the string. And it's a very simple string. It's just a string with an integer. And so we incur this cost, and we don't need to. With a lambda expression where we just create the recipe and don't do the string building stuff, we get the same performance as if we'd passed in a static string. So this is a good thing. This means that using lambda expressions to implement lazy evaluation type patterns is going to give us a performance win. All right, lambda expressions. We've got 42 minutes for collections and streams. Good. The simplest place where you might want to refactor collections and arrays is to, instead of use a traditional for loop, and use the for each method. So for each is available on the streams API, but also on a bunch of collections. So you don't have to just do collection.streams.forEach. Things like lists have for each on it anyway. And IntelliJ will work out which one you want to use. So let's have a look at some examples of this. Here we've got an inspection which says, So these are all under Java language level migration aids, which you can't read because I can't read it and I'm here. Okay. All right. So the kind of simplest example of this is where we have a set in this case. We're iterating over that set and calling some method. So IntelliJ suggests that we can just replace that with a for each. And that's nice and simple. We just lose all of the for loop and simply say, look, for every one of these things, call this method. So that's a really nice, simple win. We can go further if we want to. We see that this variable is only used here, so I'm going to inline that. And then we see this variable is only used here, so we can inline that. So I've basically just got rid of a whole bunch of code, and now the code is a bit more descriptive. It says, look, for all of these types, just do this thing. Okay, let's look at a more complicated example, because, you know, life is usually more complicated than this. So here we have a for loop, an if statement, and then we're adding something into another collection. So let's see what IntelliJ wants to do with this. Well, that's quite nice. It got rid of a whole bunch of code for me. I'm not sure I can parse what the other thing does, but it got rid of code for me. Now, if we look at the before and after, what we've basically done is this for loop has turned into a for each. This if statement has turned into a filter. And then this code, which is the new call, gets put into a map. And in the end, everything is added to this collection. So that's kind of cool. It's an improvement. It's not perfect because we've still got another for loop up here. But it's an improvement. And here I'm using IntelliJ IDEA 2016.3, which is due out any minute now. And this refactoring is an improvement over the refactoring available in 2016.2. And I know that because I gave this talk for 2016.2, and this morning when I did this refactoring, I was like, what is that? It's totally different and much better. So this is kind of cool. This is moving in the right direction, but not perfect because we still have this other for loop. But you might choose to take some of these automatic refactorings to move you in the direction of using Java 8. Or you might look at this and go, oh, well, actually, this is a bit of a smell because really we shouldn't be doing for loops followed by for loops followed by for loops. Perhaps we should be restructuring our data and rethinking about the way we do our stuff so that we can use a single stream operation. The last example is another fairly complicated example. Okay, I did say. Here we have an if statement. I didn't make any of this code up, by the way. This is real code. An if statement, a for loop, an if statement, a for loop, an if, and then an else. Now, because we've got an if and then an else, this has got two different code paths. So we know we can't refactor this. We can't refactor away the if and the else inside the stream pipeline, because the stream pipeline really only does one thing. But let's see what IntelliJ can do with it. We can replace it with a for each. Now we have a stream, a filter, a flat map, and a for each. So let's see what bit went where. We've got two for loops. So the for loops got collapsed into a single flat map. So that's quite cool. That means we're now doing a single pass, a single iteration. Our if statement predictably went into a filter. So we kind of have a little bit more readability here. We have our if in a filter, and we have flat maps so that we're doing everything in just one pass of the data. We still have, as I suggested, my if-else and another if up here. So for me, I think the fact that this can't be automatically refactored to a simpler stream operation suggests that I have to take a look at my design, step back a bit further, and see if there's a better way of creating this operation, basically, so I can do a single stream operation. Okay, so we did that. Let's look at the performance of these things. So here's one where we did the really simple collapse into using a single for each. And in this case, we have the performance is more or less the same. So that's great. We can go ahead and collapse that without worrying about any performance implications. And with the first complicated example, where we ended up with a flat map, we also get very similar performance. However, if you look very closely, you'll see that the performance is actually pretty horrible because in the original and refactored, we're getting 0.6 ops per millisecond, which is it's not very many. So I think in this particular case, the cost of the operations we're doing inside the loop is so high that any cost of doing the actual loop iteration doesn't matter. So it doesn't matter how we're iterating over those collections, we still get the same performance. On this slightly more complicated example where we did a stream and a filter and a map and a for each, we find that the refactored code is not quite as performant. And here we see the performance wasn't as horrible to begin with. We're getting sort of 1,000 operations per second. So here I suggest that perhaps because it's a faster operation that's happening inside the loop, we have a slightly higher cost for using streams than using the traditional for loop. So that's something to be aware of. So sometimes using the new patterns will not make a difference, and sometimes the new patterns might perform slower for you. So definitely somewhere, an area where you probably want to do performance tests if it matters for you. Okay, the next easy refactoring for loops is to turn it into a collect. So a collect is where we were iterating over some collection, looking at some values, and then pulling them out into another collection. Escape that, go over here. All right, so our first example here, this is a kind of typical piece of code. We're going to iterate over a list of keys. We're going to pull out the ID of that key and put them into a list of IDs. So this happens to be initialized with an initial capacity, which may or may not be a premature optimization. I'll performance test that later. If I take that out, then I can refactor it directly into a collect. I'm going to inline that. So we've got rid of all of our boilerplate around our for loop, and we just basically do a map to get our ID and a collect into a list. So it's a bit simpler to understand what that code is doing. Okay, and the next example. Here we're iterating over an array of fields up here, and we're putting things into a list of fields. So we're going to filter out a bunch of different values and put them into a list. So if we refactor this, I'm going to inline this variable. Now it's kind of a little bit icky because what we have here, which you can't even see, is some slightly complex logic around which values we care about. And I can get a clue for what that is because look, I've got a comment here which says, we ignore static and final fields. Now I'm not a big fan of using comments where you don't need to, so I suggest we refactor this into a method which says, is not static or final. And then I don't need a comment to say I only care about the non-static or final fields. So now my code is much, much simpler. I just got rid of all this nonsense and simplified it down to a single collect. Notice, however, that because we're iterating over an array of fields, we have to use arrays.stream. So we're going to create a stream from an array there. So let's look at the performance of this. So this was our simple, I want to performance check 3 things here. One is our original code, which had the initial array size. The second one is removing the array size to see if it mattered. And the third one is to use the refactored code. Now, it turns out that initializing the array to the correct size for an array of size 10 really makes a difference. You get much better performance for that sort of thing. And our refactored code is the orange bar is not looking so great performance-wise for an array of 10 elements. Over there, on the far end, where you can't even see it, the tiny yellow sliver is if we added parallel to magically speed this up. I'm glad you're laughing. For 10 elements, parallel is not going to do anything for you, okay? Because you've just basically split it up over a bunch of cores and like farmed it out over here and then had to pull it all back together again for 10 elements. It's completely pointless. Where parallel starts to come into its own is with my performance tests, I only really start seeing good performance from parallel around 10,000 elements. Okay, so like 100 elements doesn't matter, 1,000 elements. So we're talking big arrays where parallel starts to matter. And then, of course, it not only overtakes the performance of my refactored serial code, but starts to get better performance than the original array code. List code. Now, the reflection utils, which is where we refactored to use arrays.stream, we also don't get much better performance for using a collect on the arrays2stream. So automatically using collect is not necessarily going to give you any performance gains, and you might want to, well, it's not going to give you any performance gains. It might give you some performance losses. So you're really going to have to consider, is this really what I want to do? Now, an area where I think streams is really interesting is to be able to collapse down multiple operations into a single stream operation. Now, developers can't always think like this, which is why we've had code which sort of iterates over one list, does a bunch of things, takes that list, thinks about something else, does a bunch of other things, and then does a bunch of other things. You can collapse a lot of those things into a single stream operation much more easily. So, to show you some examples, here what we've got is we are iterating over a collection, it's a set actually, and then we're going to put some values into another list, and then we're going to sort that list, and then we're going to do something else with it afterwards. So IntelliJ IDEA suggests we can change this into a collect statement, and in fact it noticed that because I had a sort call at the bottom after the for, it can just add sorted into my stream operation. So it's just collapsed that into a single operation. That's pretty cool. But we can go one step further. The IDE hasn't noticed this, but we can notice this. What are we doing with this list? Well, we're going to iterate over it again and do something. Well, that seems kind of silly. I don't need to do that. I can just say, for each of these log lines, do logline.log. And then I don't need to assign it to anything because I'm not doing anything with it. And I can get rid of all this code. So this, I think, is where streams give you the big wins. Okay, I've just collapsed down 2 for loops and a sort operation, which is effectively also doing iteration, into a single operation. Let's look at another example. So here we have, it's not obvious that there's a bunch of operations going on here, but we are doing, we're looping over one collection, and then we do something else to that collection at the end. So this is also initialized with an initial capacity, so I'm going to get rid of that and refactor this. So that gets replaced with a collect statement. Now what happens to it? My fields, I end up calling toArray on that because it needs to be an array because I'm passing it in as var args. So let's simplify this code, drag this out, field array, inline this. So now I have a single operation. I'm doing a stream, a map, a collect, a to array. Be warned, this is not a single operation. The collect is the terminal operation from the stream. The toArray happens on the list that was the result of the stream operation. This is not a single operation, this is still 2 operations. However, we can still win, because actually you can just call toArray straight away with a method reference, and we've just collapsed that down into a single stream operation. So, this is exciting, let's look at the performance. So our mapping validator, where we collapsed our 2 loops and a sort operation into a single stream, yeah, we get better performance from our refactored code. It's marginally better, but it is better performance. So this is definitely a good thing. Now, the other thing I wanted to test is my original code. Where am I? What am I looking at? My original code, and oh yes, and I want to test the code with the naive refactoring to the collect followed by the 2 arrays, and then the updated refactoring where we go straight to arrays. So here we see that the naive refactoring is not quite as great, but when we do a single stream operation, the performance is as good as doing the original code. So I'm saying inconclusive because the performance it depends, and it's not substantially better in all cases, but you have the choice there of refactoring to use Java 8 idioms and knowing that it's not going to negatively impact your performance. All right, 26 minutes. Great, we've got loads of time. We're doing really well. Why did I say that? Something terrible is going to happen. The demo gods hate it when you say things like that. Right, any match. This is a new refactoring in IntelliJ IDEA 2016.3. We are going to type converter. Now again, this is kind of typical sort of code that we'll find in our code base. You're going to iterate over some array or some list or something, look for some criteria, and then return true or return some value, otherwise return false. So this can be automatically refactored into an any match, because that's what the any match feature does. Okay, you're basically going to find if anything matches some criteria. Again, note that we have to use arrays as stream here because we're talking about an array here, not a collection. IntelliJ also wants me to replace that with object.equals, which is kind of fine. It stops you making silly mistakes sometimes with null pointers, etc. So that's kind of cool. Let's have a look at the performance of this. Must be a keyboard shortcut for that. One of the good things about this, of course, is that we can use the magic parallel incantation to make everything better, right? All right, using any match on type converter. The performance of using any match is substantially worse than the performance of iterating over the array to begin with. Of course, parallel doesn't work. This is for 10 values, so parallel gives us nothing. Looking at it for 10,000 values, we're still not really getting any closer to the performance of just iterating over the array. And at 100,000 values, then parallel overtakes the refactoring without parallel. But the thing is that array operations can be extremely efficient, especially trying to find the first value in an array. It can be very efficient for the CPU and the compiler and basically all parts of your machine to iterate over an array. So sometimes using the new idioms is not going to give you better performance than that. So any match may not perform faster. However, there is a caveat to that. I think it might actually be the arrays.stream which is going to slow down your performance in this particular case. We've got a similar thing where instead of any match, which returns a Boolean that says, does something match this criteria, we have find first. So give me the first value that matches this. For example, we are going to iterate over some values and return the first thing that matches some criteria. IntelliJ has done the kind of, I guess, super smart thing. It's now using int_stream.range instead of using, if we look at the original code, instead of doing a for loop with a 0 up to whatever length is, we can use int_stream.range. It's also using map to object so that we can get the value we want. It's using filter and it's using find first. So we've got a fully stream compliant piece of code here, which is cool, I guess. Let's look at another example. Now here what we're doing is we create a new array. Hold on. We create a new array of 4 values. And then we iterate over that to find out if we actually have any of the values in the class that we're looking at. And that's kind of, let's inline this. And we can't see this because the code is so ridiculously long. So that's kind of fine. We can create arrays.stream of this array that we created of 4 values. We could do something a little bit simpler. We can get rid of this. We could say stream.of. And we can give in those values, so we don't have to mess around with creating any array stream. Instead of creating an array and then passing it to arrays.stream, we can just say stream of these individual values. And then we're going to use our filter and our find first. Okay, that's kind of, I guess it's a bit more readable than our for loop with our if statement. And our final example, whoops. This is kind of a more classic example where we have some collection. We're going to look for anything which meets this criteria and return the first one we find. Otherwise, return null. And again, IntelliJ's kind of figured out that this whole for loop can be collapsed into find first, but also that our return null gets collapsed into an or else. So we can kind of add that value as the I didn't find it value. Okay, so that's find first. Let's look at the performance. Shift F5, thank you. It's killing me. What was I doing? Find first. Right, so this is the one where IntelliJ uses an int stream instead of using iterating using sort of traditional indexed iteration. And not really super surprisingly, the Java 8 code doesn't perform quite as well as a classic iteration, because really there's just, there's just not that many values, so you're just not going to have, you're creating a whole series of objects and a new int stream and a new this for a fairly simple application, a fairly simple example. Find first, this one where we've got 4 values that we're iterating over. We can either do arrays.stream with the array or the stream of. So I want to performance test all those things. Regardless of which of the 2 refactored options I take, the performance is just not as simple as doing a simple for loop, because there's 4 values in there. I mean, it's not that complicated. And the last one, where I think it's more readable and a little bit prettier to use the find first. Again, we're just not getting better performance out of that. That's for 10 elements in the list. However, of course, as you add more elements to the list, and if you want to parallelize it, that's when you start to get the performance gains of using streams. So find first, migrating to using find first, I would test it before jumping straight down there. If you want readability, it's definitely more readable. If you want better performance, well, you're going to have to see. My final example is a new method on collections. This is not part of the Streams API, which is remove if on a collection. Let's look at this. Entity scanner. Now here we had a piece of code where we're using an iterator, we're looking at every item, and then if it meets some criteria, we're going to remove it from the iterator. IntelliJ suggests, where did all my code go? It just basically gets rid of all of the iterator creation, all of the iterating over the iterator, most of the comparison, and sort of the actual remove thing. You end up with a single line of code, which is much more descriptive. It just says, from this collection, remove anything that meets this criteria. So that, I think, for readability is a massive win. Let's look at performance. Oh, I forgot the keyboard shortcut already. Shift F. I'm not going to have to do it again now. I'm not going back out of the presenter anymore. I don't know where I live now. Right, remove if. It's much prettier, and the performance is better. So I've said inconclusive because I wanted to say win, but basically the performance is marginally better, so you can go either way. But given how much readability you get from using remove if, I would say, and the performance is marginally better, this is definitely a win. Right, summary of findings. So I have a summary and a conclusion, a bit like some sort of, I don't know, science project. Refactoring to using Lambda expressions is very easy to automate. You saw me just kind of applying those across the board. And pretty safe performance-wise. There's no sort of major gotchas to worry about in terms of moving anonymous inner types to Lambda expressions. Designing to use Lambda expressions in your method calls so that you can do things like lazy evaluation can give you some enormous performance wins as well. So that's a good thing. Generally, a lot of the new idioms in Java 8 really do increase readability and decrease clutter. Some of it's going to take a little bit of getting used to, but generally speaking, you have less code. For example, obviously, Lambda expressions is a lot less code. Using for each for simple cases is way less code, arguably more readable. Using a collect statement can also get rid of loads of code. Any match, we saw we removed loads of code using any match. Find first is a bit more readable. Remove if is definitely my favorite. We just get rid of all of that crap and just have a single method call. And particularly if you're using multiple operations, which you can shrink down into a single stream operation, this is where you get your big readability wins. So this is where we got rid of 2 for loops and a sort operation into a single stream operation, which is much more readable and was better performance as well. And again here, where we got rid of a for loop and a to array and just collapsed those into a single stream operation. But be aware that obviously using the Java 8 new idioms, new APIs, there will be some performance implications one way or another. So for example, arrays.stream is probably always going to be slower than using an array. The reason to use arrays.stream is if you can go parallel and you're talking about big arrays. But generally, we found that the arrays.stream is a lot slower than just iterating over an array. Using for each or collect may be slower than iterating over a collection. It depends a little bit. There's not really that much in it. Like half the speed is not that much of a big deal in the grand scheme of things. If the thing you're doing inside the loop is quite expensive, then it doesn't matter whether you use a for loop or a for each, or whether you use a for loop or a collect. Parallel is probably not going to give you any speed improvements in most sort of day-to-day coding areas, unless your data is very big. So we're talking 10,000 elements or more. Then you're going to start to see the improvements of parallel. Or if the operation that you're doing is very expensive and you want to farm that out over multiple CPUs or multiple cores. But there are some cases where you end up with improved readability and better performance. For example, my favorite, remove if. I've got loads of time left. What happened? Right. Conclusion. So there'll be time for questions, which is novel, and I'm not sure I'll be able to answer any of them. In conclusion, should you migrate your code to Java 8? It depends. Of course it does. And I haven't even I talked a little bit about the safety nets that you need to apply before you're doing the migrating, but you do really have to think, is there a lot of value in messing around with an existing system that works perfectly well just to start playing around with lambdas? So it depends. You have to remember what the goal of your refactoring is. So the goal might be performance, it might be learning, it might be readability, it might be so that you can use the code amongst developers who are used to using more functional styles, for example. And you have to compare the results of your refactoring to that goal. So some of those refactorings where we still ended up with like a for loop with a stream inside and then an if-else, I mean, you're not getting a lot of value from doing that sort of refactoring. So it's okay to back these things out and decide not to apply them. You need to have some sort of understanding of what may impact performance. Streams are kind of cool. In fact, streams are very cool, especially if you can do multiple operations in a single stream. But it's not clear which things are going to be better performance than others. There are 2 blocks of code in this example where the refactoring looks almost exactly the same, and one performs the same as the original code, and the other performs worse than the original code. So if you're not really sure what the impact is on performance, do measure those things. Your tools can obviously help you. So IntelliJ IDEA, NetBeans, Eclipse, they are going to suggest places where you can perform these refactorings. And that's great, and we should use those things, especially if we can automate things like creating Lambda expressions from anonymous inner types. But as you saw, quite often, you have to have a look at the code and think about what more can we do? Is there an additional refactoring, or is this a kind of naive approach to doing this? So it's very much down to us to look at each individual case and go, okay, what is this giving us? What more could I do? Yeah, that's bad. And I'm supposed to have a link to further reading, which clearly I deleted right at the start of this talk. Yeah, magic. Shift F5. Yeah! Thank you. Yes, thanks very much. So yes, I have time for questions, obviously. And this is links to all references. So it's all the code that we refactored, all the performance tests, all the performance test results. These slides aren't currently live yet, the updated ones. I will put them up probably sometime before next week, probably on the plane tomorrow. Any questions? Oh, yes.
Yes, excuse me. At the beginning of Java 8 and the introduction of streams, there was a lot of bashing on the performance as well. A lot of people micro-benching it, and the results are
Right. So to summarize the question, at the beginning, people were complaining that the stream performance wasn't always amazing. Over time, performance has generally got better because tuning can happen under the hood while the API stays the same. And the question is, should we kind of persevere with streams, assuming that things are going to get better? And I would definitely say yes. I mean, my initial benchmark results from the start of this year have already improved by the end of this year by running on the most recent version of Java 8. So Java 8 continues to get faster. It is better than it was. And as you say, like a lot of these tests were micro benchmarks, and micro benchmarks are not super important sometimes in the grand scheme of things. This library is for talking to the database. So at the end of the day, if something is half as fast in the code, the call to the database is going to way outweigh that, in which case applying things like streams or any of these other things which aren't so great performance-wise is not going to be a problem if you're talking about end-to-end performance. Does that answer your question? More questions? Yes? What about debugging? That's a very large question. Debugging, that's one of the reasons why I wanted to show extracting the Lambda expression into a separate method. Debugging for streams and lambdas is an acquired skill. It's a little bit different. IntelliJ is much better at it, obviously. You can do things like put breakpoints in streams, and your IDE will help you with that stuff. But yes, debugging streams is interesting, and quite often, if you're in the process of debugging, you want to deconstruct it out into a series of steps maybe, or a series of methods, so that you can breakpoint at the appropriate places. Does that answer the question? More questions? I think that's it, but feel free to come up and pester me either now or find me at the JetBrains booth anytime today, apart from when I'm speaking. Thank you very much.